Hey everyone, I wanted to send you a video that will help you with your equation calendar project. What I've asked you to do on this project is to create an equation with a specific solution. You are supposed to choose a month, and you are supposed to write an equation to represent each day of that month. You're required to write 4 weeks worth of equations and for those specific days. So you will start with the first full week, whether that be Wednesday to Wednesday or Sunday to Sunday or Monday to Monday, whatever you want to do. Or you can make an equation for each of the for each day within the month. But I just want to show you how easy that is. So, of course, the days of the month are numbered from 1 to 31. So, if you wanted to do an equation for the first day of the month, you would say that your solution is going to be 1. But since I want you to do those, I am going to do an equation with a solution that is not between 1 and 31. So let's say I wanted to make an equation with a solution of 40. Here's how I'm going to start. If I want my solution to be 40, I am going to write that like that. Now, to create a one-step equation, I do one operation to the variable. Now, that operation may be multiplication, division, addition, or subtraction. It doesn't matter, okay? So, let's do one of each. So, let's say x is 40, and I wanted to do an addition problem with that. So, I could say x plus 6 equals 40. But right now, those two equations do not match. Because I added 6 to the x, I also have to add 6 to the 40 to keep it balanced. So, if I wanted my solution to be 40, I would then say x plus 6 equals 46. Then I could solve that equation to see if it really did equal 40. And of course we know it does, because if I plugged in 40 for that, I would get 46. So that is how easy it is to create an equation, a one-step equation, when I want a specific solution. Now, of course, I could do subtraction. X minus 10 equals 40 minus 10, because I have to do the same thing to each side. So then, x minus 10 equals 30. And if I were to solve that, plug in 40. 40 minus 10 is 30. Or I could do multiplication. 3x equals 40. Probably shouldn't have used 3. It's going to give me a repeating decimal, but that's okay. So 3x, oh no, it's not. Never mind. What am I thinking? 3x equals 40 times 3 because I multiplied by 3 both sides. So x equals 100, or 3x equals 120. And if I were to put 40 in as x, I would get 120. I could also do division. Alright, so now that is your one-step equations where one operation is happening in the equation to solve for x. I have to do subtraction to get rid of this positive 6, so this is a one-step equation. I have to do addition to get rid of this negative 10, one-step equation. I have to divide by 3 to get rid of that. Now, I am going to take this same equation, x equals 40, and I'm going to turn this into a two-step equation. Now, remember, I started with x equals 40, and then I changed one of my equations to x plus 6 equals 46. Now, I just do one more step. If it was addition, it's real easy to add a multiplication problem to this. So I'm just going to multiply both sides by 2. Okay? All right, so if I multiply this side by 2, I'm going to have 2x so I'm going to multiply both sides by 2. Now, when I multiply both sides by 2, it's actually a distributive problem, property problem. So I've got to do both the x times 2 and the 6 times 2. And then 46 times 2 would be 92. There is my two-step equation. And of course, if I were to solve that, I would subtract 12 from both sides. I would end up with 2x equals 80. Then I would divide by 2, and I would get x equals 40. So, all I did was multiply both sides by 2, but I had to use distributive property to get that answer. Now, in this case, I could do it the same way. I could multiply both sides by 2. I had x minus 10 equals 30. Reading the wrong line, that should be 30 because there's my equation. Okay, then I'm going to multiply both sides by a number. We'll do 3 this time. So 3 times x is 3x. 3 times negative 10 would be negative 30. And 30 times 3 would be 90. Okay, so then there is my two-step equation. And just to see if it worked, add 30 to both sides. I get 3x equals 120. Divide by 3 both sides, and x equals 40. My solution is still good. So, in this case and in this case, all I did was take a number and multiply by both sides. And remember, if there's two terms, I've got to multiply both terms by what I'm multiplying by. Okay, now if I already had multiplication here, my equation is 3x equals 120. Well, I could just add or subtract from it. So I could do 3x plus 6 equals 120 plus 6. And my two-step equation would be 3x plus 6 equals 126. And of course, to prove if that works, I would subtract 6 off of both sides. I would get 3x equals 120, divide by 3, and x equals 40. So, pretty easy. One-step equation, two-step equation, no big deal. Now, let's go to a multi-step equation. Now, remember, when you're writing all of yours, you're having it equal a different number. So if you're starting off on the first week for a one-step equation, you will have 1, 2, 3, 4, 5, 6, 7. So you'll write a one-step equation that equals 1, a one-step equation that equals 2 instead of 40, and a one-step equation that equals 3. You'll change your x equals every time. Then when we go to the two-step equations, you will be doing x equals 8, 9, 10, 11, 12, 13, 14, and so on. Now, for your multi-step equation, you start with a two-step equation that works, right? Well, we really start with a one-step equation, make it, add on your second step, and then with the multi-step equation, we just go one bit further. So, 2x plus 12 equals 92 was our first two-step equation. To make it a multi-step equation with variables on both sides, we just add a term to the side with the variable on both sides. So I could add 3x to this side. If I do it to this side, add 3x to this side. Now I'm going to go ahead and combine like terms to simplify. 5x plus 12 equals 92 plus 3x. There is my multi-step equation, equations with variables on both sides. Okay, so now to solve it, I'm going to move all of my x's to one side, all of my constants to the other, all of my variables to one, all of my constants to the other. And remember what I always said, I would prefer not to have a negative variable if I can help it. Just my preference, it doesn't matter. Okay, Brady always did it the opposite, if y'all remember, and he always got them correct. So he liked having a negative variable, and that's just fine. So I am going to move this 3x off of this side. So to get rid of this positive 3x, I subtract 3x. If I do it to one side, I do it to the other. Now, since that's gone, I want to get this 12 off of here. So I'm going to subtract 12 from both sides. And I get 2x equals 80. And then when I solve for it, guess what? X equals 40. So, one-step equation, take your solution that you're looking for, add, subtract, multiply, or even divide by something to get a one-step equation. Then, to make a two-step equation, you create a one-step equation that equals that amount, then multiply, divide, add, or subtract from it, whatever you want to do. Then for a multi-step equation, you take the same two-step equation and you add a term to it, a term with a variable. Okay, so I'm going to show you one more. I said I wasn't going to do one, but I will. I will do 31 for you, okay, because you only have to do 28 of the equations. So I will show you how to do x equals 31. Okay, so here we go. X equals 31 is my solution. This is what I am writing for the date. So if I was making this a one-step equation, I would do one step to both sides. So it's going to be real easy. I'm just going to add to both sides. X plus 6 equals 31 plus 6. Now, I had to add 6 to both sides because I had begun with this statement, this equation, x equals 31. Now, I'm adding 6 to both sides. I cannot add these together because they are not like terms. I can add these together because they are like terms. And now, just to double check myself, if I were to solve this equation, I would subtract 6 from both sides. X does equal 31. But I don't want just a one-step equation. Maybe I want a two-step equation that equals x equals 31. So I'm going to take and I'm going to multiply both sides by 2. Remember, distributive property. Anything outside goes to the inside. 2x plus 12 equals 54. Okay? 64. I knew something was wrong. All right, there we go. 2x plus 12 equals, no, my goodness gracious. See, I've got to think too. That is 74. See, I know y'all missed me and all of my mistakes that I make. Okay, here we go. So, if 2x plus 12 equals 74, because 37 times 2 is 74, and 2 times x plus 6 is 2x plus 12. If I were to solve for this, I would subtract 12 from both sides, which would leave me with 62 over here, and divide by 2, which would give me 31. But let's just say I didn't want a two-step equation. So I am going to add a variable term, a term with a variable. So I'm just going to say I'm going to add, let's do 4x to both sides. And now I combine like terms. 4x plus 2x is 6x. 6x plus 12 equals 74 plus 4x. And then if I were to solve for this, I would have 2x plus 12 equals 74, and we've already solved that. So, one-step equation, do one operation to your x and your solution, the same operation. Two-step equation, take the one step and do another operation to both sides. And in a multi-step or an equation with variables on both sides, add a term with the variable to both sides, or subtract, or divide, or multiply, whatever you would like to do. I hope this helps you. Remember that we will be online at 1 o'clock every day this next week. So come and see me. Ask me questions if I need to. Your invite is in your email. So don't forget. Hope this helps. Let me know if you have any questions.